now look at how to calculate a confidence interval if we don't have the population standard deviation. In this case, our formula is given by x bar minus t star times s over the square root of n is less than mu is less than x bar plus t star s over the square root of n. So this t star times s squared of n, this is going to be my margin of error. The big differences between this and a known standard deviation is that I'm going to use the sample standard deviation rather than the population standard deviation, and we're going to be using the t-distribution rather than the normal distribution. In order to find t star, we will be using r, and the command will be qt times 1 minus alpha over 2, comma n minus 1. N is our sample size, and n minus 1 is our degrees of freedom, and alpha is going to be the opposite of the confidence level. So if our confidence level is 95%, alpha would be 5%. Let's suppose we discover 8 fossil skeletons for a new species of bird. These skeletons showed that these birds had an average height of 12.3 centimeters with a standard deviation of 1.4 centimeters. And we want to find a 95% confidence interval for the true height of this new bird. The first thing we need to do is find our value for t star. In order to do this, we use the command qt. Since we have a 95% confidence interval, alpha will be 5% or 0.05. So 1 minus 0.05 over 2, comma 8 minus 1, since 8 is my sample size. Typing this into R gives us the value of 2.36. Next, let's look at our margin of error. This is given by t star times s over the square root of n. We just found t star. S is our sample standard deviation, which is 1.4 centimeters, and our sample size is 8. Plugging these numbers in gives us a value of 1.17 for our margin of error. Our final step, we want to add and subtract 1.17 from our sample mean. So x bar minus 1.17 is less than mu is less than x bar plus 1.17. And our average height, our x bar, is 12.3. Plugging this in and completing our calculation, we get that the true mean is somewhere between 11.113 centimeters and 13.47 centimeters. And we can say this with 95% confidence.